The inverse of a function is formed by interchanging the x and the y values of the function. It is interesting to note that the domain of the inverse function is the range of the original function, while the range of the inverse function is the domain of the original function. When you substitute the inverse function as the input for a function, the output should always be x. Since a function and its inverse are both inverses of each other, the reverse is also true. We'll now look at some examples where we verify that a function has an inverse. Consider the function f of x is equal to x over 5. We will verify that f inverse is 5 times x. The fact that these are inverses should make some sense. On the one hand, we are dividing by 5, and on the other hand, we are multiplying by 5. Here I am showing the substitution, replacing the x with the definition of f inverse of x. By simplifying, we get x. However, we still need to verify that the reverse is also true. So here we are substituting the definition of f of x into the inverse function. By simplifying, we once again get x, verifying that f and f inverse are in fact inverse functions of each other. We'll now look into another example where we verify that two functions are inverses of one another. Here our functions are f of x is equal to 3x to the 5th power minus 2, and g of x is the 5th root of x plus 2 over 3. First, I will substitute the definition of g of x into f of x. Here I have highlighted in blue g of x, replacing where x appeared in the definition of f of x. Here the 5th power cancels with the 5th root, leaving us with just 3 times x plus 2 over 3 minus 2. Multiplying and dividing by 3 will also cancel out, leaving us with just x plus 2 minus 2. Finally, these 2's also cancel, and once again we are left with just x. As before, we do need to check that the inverse works both ways, so now we are substituting the definition of f of x into g of x. I have highlighted in blue in this example where f of x appears in the definition of g of x. Once again, we simplify by canceling, leaving us with just the 5th root of 3x to the 5th over 3, where we can continue to simplify, canceling out the 3's, and then canceling out the 5th root and the 5th power. Thus, we have shown that these two functions are indeed inverses of each other.